Okay, good. I hope you can hear me well. So we are starting now. For the newcomers and for people who are joining just now. Yeah, I'm software engineer at Microsoft. We are here at Microsoft office on this beautiful terrace. And as I promised, I don't know, months ago, we're gonna stream from the terrace. And today is the second day we are streaming from the terrace. And I guess this is beautiful. So today we don't have that much time, I would say. So today the plan will be is to have system design of Messenger like WhatsApp, I don't know, Telegram, whatever, which I didn't prepare, so I didn't read before about this. Let's see how it will went, and also we're gonna review the same design from one very clever and experienced guy. He has his YouTube channel, and this is staff engineer from Meta, so his level is much better than mine, of course. So we're gonna check what mistakes did we do, what we didn't consider and stuff like that. But before, we're gonna design it on our own. And also, besides that, we're gonna do a LeetCode question, our LeetCode 75 list, and maybe we're gonna do something else. But yeah, in general, I would say, yeah, let's start straight away. So yeah, what do we start? Should we start with LeetCode or with system design? Let's start maybe with the LeetCode question. So find a peak element. So peak element is an element that is strictly greater than its neighbors. In this case, this should be 3 because 1 and 2 is less than 3. In this case, it can be 2, it can be 6. Also for this reason, because the element to the right and element to the left are strictly less than current element. And we're gonna our task is to find one of such peaks, pick any possible one. The problem is that we're gonna implement the algorithm that runs logarithmic time, not linear, because linear it will be pretty easy, just scan everything and compare left and right. Also, one peculiarity here that in case there is case like this, so we have 4, 3, 4 gonna be peak element because we kind of consider if it is the first element, then the element to the left is kind of done for us, so it should be okay. So how do you feel about this question? I would say straight away that yes, if you see log n, and this is something that you need to find in array, most probably interviewer and the task itself is about binary search. So this is what we're gonna do, but the problem is that it is not an easy binary search, right? It's not like the collection is not sortable. I mean, if it will be sorted, then we would just take the right element and that's it. So how are we gonna approach this problem? So let me actually take a picture and let's draw as always. Meanwhile I'm watching the chat. Chat is empty so far, but that's all right. So So how do I approach? So how, in general, binary search can be applied here? So let's say we have left element here. Oh, sorry, it's very hard to write. And right element here as the last one. And let's say middle one would be this one. So in this case, we kind of gonna observe the middle element. And what can we conclude from this? Also, the tricky part that numbers are not unique here. So as you can see, we might have same numbers, but they cannot be adjacent to each other. So it means that nums I is not equal to nums I plus 1, which means we cannot have consecutive ones, which is great because it's easy to compare middle with the right element and with the left element. So now, what should be our intuition? So clearly, we can compare 3 is less than 5 and 3 is bigger than 1. So what does it mean? That 1 is definitely not the peak element. 3 is not the peak element either. There might be peak element somewhere here, and there might be peak element somewhere here. But it might not. To the left, because let's say we don't know what is it here and we don't know what is it here. clearly we can conclude that there should be a peak element to the right. Why? Because at least the neighbor, the adjacent number, is bigger than 3. It means if there is nothing at all, it is peak number if it's the last one. Also, if there is some bigger number, I don't know, can be 9 or 6 in this case, perfectly fine, then peak number gonna be 6 or something behind the 6. If it's less, let's say it's 3, the same 3, it means the 5 is the peak number, so it's kind of clear that it is pretty safe to go and check this part of the array. However, yeah, we are missing this peak number, but we can return any of them, right? So it means that it's pretty safe and kind of proven that we can go to the right part. And now it's right part. Let me remove these guys. And to the right part we have left here, middle here, and right here. And in this case we clearly can state that 6 is our guy, right? So because we can check just adjacent ones, and that will be it. That will be it. So I hope the algo is pretty much, understandable. And now we can just proceed. Yeah, just checking with the chat. Yeah, nice. So how are we gonna do this? So as in general, we are doing it as typical binary search. So left gonna be this one, right gonna be length nums -1, while left less than right. Yeah, I would say we don't need equal here because we don't search for the specific element. We don't search for specific element. Good. And now what we're gonna do? So first couple of cases, I would like to cut off the cases when we have left element and right element as our middle. So our middle gonna be left plus right minus left divided by 2. This is our mid. It always gonna be the middle element or the one before the middle. If the numbers is even, so if we have only 2 elements, it's gonna be 1. So yeah, let me actually draw it as well. So I don't parse the mid calculation anymore because after so many binary search questions. So for you, the easy way to think about this is when we have element x and y, only 2 elements, mid is gonna be the left one because it's even. Same if we have x, y, z, k. Since the middle is here, but we don't have this element as we have even number of elements, the middle gonna be just 1 to the left. And if we have odd number of elements, let's say k and j, the middle gonna be this one. Yeah. And for one element, middle gonna be the element itself. These are the cases you should keep in your mind to not bother yourself anymore about this. So now what we're gonna check if mid is equal to 0, which is our first case when we have just this element. What we should return in this case. If middle is this one and this is our close, it means we have 2 elements and we need to return just the bigger of them, but not the element itself. Instead, we should return the index. So we return left if nums left bigger than nums right. We know they cannot be equal as adjacent elements cannot be the same. Else, return left if nums left more than nums right. Oh, sorry, nums. Yeah, let's not involve left because left is gonna be equal to mid in this case if we have 2 elements. In other case, we return right, and exactly same cutoff we're gonna do for if mid equals line nums -1, so means it's the last element. In this case, we also gonna have just I would say 2 elements in this case, and we're gonna return any of them. No, actually, yeah, I believe so. So we return yeah, we return mid if wait a bit. Yeah, so we return, actually maybe we can just return mid, because if our mid is the last one, it means left, it is left, so it means this clause cannot be reached at all, I would say. And now our general approach, general algo. So let me also again draw it. So in this case, if we have middle as a tree, this is left, this is right. So how we're gonna proceed? We're gonna continue our path to the element that is bigger among adjacent elements to the mid. But yeah, actually, I think in this case we should do this to not keep calculating. Let's leave it for now. If nums mid more than nums mid minus 1, also one thing we should do here. If len nums equals 1, we just return index 0. It's the only one that is the peak. Else mid minus 1. Exactly. And now what we're gonna check? If nums mid, so our middle element, is less than right, is less than adjacent. Oh my god. Less than nums mid plus 1. Then we move our binary search window to the right. So it means left is gonna be mid plus 1. Else if nums middle is less than the one to the left, so nums mid minus 1. All right. Then we're gonna move right element. So in case this is not 1 but 7, we can go this way as well, and 7 gonna be peak element in this case. Yes, nums mid less than, yeah, exactly. So in this case, we're gonna move right mid minus 1, so to the left. In other case, when middle is not less than left, middle is not less than right, it means it's bigger than both of them. Let's say it's 8. In this case, this is peak element. We should return it straight away. And let's default to minus 1, just in case. But this should not be true if we always can guarantee that there is peak element. Let's actually try to run it. It passed. Of course. Okay, let's check how this guy would look like and why it didn't pass. So in this case we have left here, right here, and 3, 3. This is gonna be the middle. In general we go here. Nice. And now we're gonna have middle as this guy. We move to the left. Right. So now we are talking about 6. And this is already, yeah. Left equals right, and we move out of this while. So in this case, as a default one, we should return left. Or right, it doesn't matter actually, because left and right can be equal. Let's use this test case and check it's gonna work. It will. I have a bunch of bugs here. Yeah, good. It worked, and time complexity here is logarithm, because every single time on every iteration we are narrowing down our search area half. So yeah, we are removing half of the search area. So every single time it 2 times less. And in general, it concludes to lock. And from the space complexity, we are operating with variables without any arrays, so it's going to be constant. Let me check the chat. Chat is completely empty. It's okay, never mind. No worries. Okay, let's continue. So what we're going to continue with? We're going to continue with the system design. Yeah, there is one more binary search question. Let's see if we're going to be on time. So, last time, what is this one, by the way? I'll check last parsed months ago. Oh, this was web crawler. Last time we did it. Yeah, actually I watched this guy and yeah, I was pretty impressed. It was really solid deep dive system design, much better than mine. But yeah, this is relimiter backend, validate, sanitize the URL, good. Partitions, okay, the internal backend. Yeah, but his system design, it was a bit about different concept. So usually, like what I learned after watching and checking a couple of system design for crawler is that actually usually the system requirement is to be able to parse some number of URLs and crawl basically some number of URLs and put them into index in some specific time. So let's say you have 10 billion of URLs, the amount of URLs you need to parse, and you need to design a system and to calculate how many infra items, so like servers, databases, whatever, you need to be able to parse it in 5 days, let's say. So this is actually pretty interesting one. But we're gonna watch this guy a bit later, and now let's design our own stuff. So what we're gonna design, I never designed it before, so yeah, there might be mistakes. System design, messenger. So what it means, what's up, Telegram, whatever. Good. This is our task for today. And basically, yeah, a few things to mention. Please don't forget to subscribe to my Telegram channel. Oh yeah, maybe before system design I can do announcements. So I guess I will go to Ireland next week. So you should actually expect a bunch of updates because I never been to Ireland. I've been only to Amsterdam. And last time, if you didn't check it yet, please go and check. Last time I went to the Microsoft office in Amsterdam, which was pretty interesting experience. First of all, the office was, I don't know, maybe 400 meters away from the airport. Oh my god, where is the office? Whatever, so you can watch it later. It was a pretty cool experience, and we worked one day. I showed the location and stuff like that. So yeah, I think I will record pretty much the same about the Ireland office. I mean Ireland Microsoft office. I guess they will let me in because as far as I know the Microsoft card is applicable worldwide, so I can go and work there, which is quite good actually. And let's check and compare it to Prague office. So yeah, don't forget to subscribe to Telegram in the description because pretty much all the updates, all the insights, private information are gonna be there, not anywhere else. So let's start with the system design, and before that, system design questions. This is what I wanted to check because there are requirements. So URL, YouTube, which is we're gonna design as well, and Messenger. I want Messenger. Facebook. Oh my god. Messenger. No, don't sign in, please. Messenger. I'm sorry, I made a mistake. I thought it's. Oh my god. No, I don't need Restream. I don't need this. So Messenger. I'm sorry. B1 English, what can I do? So, global chat service. Design a global chat service like Facebook Messenger or WhatsApp. You need to focus on real-time communication, scalability, and reliability. Start with the user management, registration, and login. I think this is completely irrelevant during your real interview question, so don't even bother yourself, like assume your user already authorized when it comes to your app. Then implement messaging using technologies like WebSockets, oh my god, this is spoiler. This is spoiler. Alert, spoiler detected. Our message storage is oh shit, this is solution, no? I don't need answers. Oh my god. I'm sorry. So you are interviewer in big tech. Give me the interview question about designing scalable high-load messenger. Let's do like this. I thought they're gonna have the clear requirements. Good. Yeah. So design scalable, fault-tolerant, high-load messaging system, WhatsApp, Telegram. How you would handle millions of concurrent users sending and receiving messages in real time. Walk me through core components, your architecture, data model, storage choices. Okay. Ensure message delivery guarantees at least once. Exactly. Oh, this is very interesting. This is very interesting question. We should not forget about this one. Oh my god. Middle. Yes, this is pretty interesting one. Let's name it as a to-do. That's good. What else? Scale to handle spikes during New Year's Eve or big sports events. Also very solid question. Online, offline users and message retries. What does it mean, message retries? Okay, whatever. You design the read receipts and last seen indicator. Oh, last seen indicators is actually the at Microsoft. This is completely separate service that I'm working on. But whatever. Yeah, in Teams when you see last seen 2 hours ago, this is my service. It's taking care of. I mean, not my service, but service of the team that I'm part of. Design read receive last seen. This is, yeah, I think out of scope. System secure. Okay, makes sense. Okay, allow for future features like group calls or message reactions without major redesign. Okay, sharding partition of data. No, answer we're gonna provide today. Okay, so, but still requirements are not that clear. But I need to start with something, right? So functional. First of all, you're gonna define functional requirements. So users be able to chat with each other and group chat. There should be some definition of how big the group chat should be and should have some limitations or not, but for now let's assume, let's leave it as is. Users be able to chat with each other and in group chat, near real-time message delivery, of course. What else? I don't know what else. I think this is pretty much the main thing. Anything else is kind of out of scope of messaging, for example, maybe permissions we can discuss or something like that, but let's leave it as it is for now. This is already a pretty huge functional requirement, but system design is mostly about non-functional requirements. So what do we have here? Hello, how much of DSA is required to apply in Microsoft? Question in the chat. So Oh, sorry, this is another laptop. Yeah, I have another laptop here just to watch the chat, whatever. Good. So I don't know, it depends on you, right? If you just fresh graduate from university and you had highly intensive course, maybe you don't need to do it at all. Because in general at Microsoft, especially here in Prague, the interview is not that hard, especially algorithm-wise. So yeah, I was shadowing a couple of interviews here. I conducted one interview on my own. It was system design, not algorithms. But whenever I saw algorithms, it's pretty basic questions just to see that you know at least something. When I was interviewing for Microsoft, I did maybe 150 questions in LeetCode. So I did these top liked questions and maybe some follow-ups for specific topics like dynamic programming and stuff like that. It was enough. As I remember, I got this group anagrams question or something like that, which was quite easy. So I wouldn't say you need to have a lot. You should have some decent one. I would say, how much of DSA? I don't know how to quantify, but maybe 150 questions would be enough. Solve these top 100 liked questions, and maybe, yeah, if you want to be extra sure, top 150 interview questions list. And if you want to be extra sure, solve also these 75 liked questions that we are solving here, these guys. But yeah, I would say you might be pretty lucky and maybe 100 should be enough for you. And 100 you can do basically in 1 month. So yeah, in chill mode, basically in chill mode, 2-3 questions per day, that's it. Okay, non-functional requirements, we're gonna continue. So, low latency first, because we want our messages to be as fast as possible. Then reliability, of course. If our one server or something went down, we don't want basically to service stop working. Then durability, history. So actually maybe, I mean storing chats and messages. So we're gonna have some kind of search engine. So if you chatted with a friend 1 year ago, you're gonna go and be able to find this chat and to see the messages. Also non-functional requirements, the ordering guarantee, which is quite interesting. I have no idea for now how we're gonna ensure this. And scalability, I guess. Scalability, which means millions of users, millions of chats, blah, blah, blah. Business as usual, I would say. So, good. Did I miss anything? I just started doing coding and done 15 LeetCode problems, dreaming of Mank companies. Oh my God, these abbreviations. When I was applying, it was FANG/Mank because Facebook changed to Meta, and it was kind of hard. And now these abbreviations, they are crazy because there is already OpenAI, some other bullshit. I heard somewhere that Netflix is out, so yeah. But I got what you mean. But I haven't made a single project. So if you don't have commercial experience, bad news for you. Unfortunately, nowadays market is very bad. So if you don't have commercial experience, you're gonna struggle a lot. And for single projects, I'm not sure you should do your personal pet projects. Better to focus on at least some commercial experience so you have your CV full. I think this is a bit more important. Also, what you can do, if you're really good, I mean, you can go to some open source and contribute to there, and then put it into the CV, which would be pretty valuable. But the most valuable would be the commercial experience. Then DSA, some 100 LeetCode questions, 200 LeetCode questions, and then system design, you should be good. You should be good. Okay, so let's get back. I want to check whether I missed anything. So we have, yeah, core data model, storage choices. We can ensure delivery guarantees. Okay. Not lost messages. Good scale handle spikes, or I don't know whether it is functional or non-functional. I think it's more functional thing. Health spikes. Spikes gonna be interesting. Users and message retries. Oh, spikes is actually interesting case because from my service I heard stories that when there was COVID boom and Teams got popular, and we as a present service, we got like, I don't know the numbers, right? And even if I know, I wouldn't share, but yeah, very huge increase of traffic, and it was like months consistent and stable incident and on call, during which they tried to upscale. I wasn't in the team yet, but yeah, so spikes in general might be hard to handle. Online, offline users and message retries. This one, is it meant to be like network interruption? Maybe yes. So yeah, network or low network. How to say it in English? Low network or pure net? Anyway, so yeah, network interruption. This is what I would mention. Oh, is typing fishy is interesting, yeah. This is follow-up, okay. Okay. So, and let's start. So first of all, let's maybe define some basic entities in our system and then move to the single node design when we are not focused on high reliability and scalability, and think about what we can do. What it should go. So yeah, definitely if we are talking about near real time, we are talking about sockets, most probably. So whether it's gonna be sockets, should it be web sockets or what sockets? I think it can be any raw sockets, but just TCP protocol, not UDP, because we don't want to miss some character, right, in your message. Message should be pretty precise. It's not video stream or music stream. So among the entities, there should be entities. There should be a message. There should be user. I don't know that. Yeah, and there should be chat. These are pretty core entities in our case. So chat might have different messages and different users. Whenever user is sending message, it sends it to the chat. Chat might have different users, different number of users. For now, it's more than enough for us. I don't know where to put it. Let's put it, I don't know, here. Now, single node design. So for sure, there's gonna be some client. I don't know, let's write some client over here. It can be anything, right? It can be mobile web. So mobile web desktop. Let me short it a bit. Oh my god, still not enough. So this client most probably gonna connect with the socket connection to our server, right? Let's not talk about middleware and API gateway yet. So it's gonna be socket server. But before that, apart the socket server, there should be one more component, which is actually not a socket server, but maybe chat server or service, whatever. And why do we need this? Why do we need this? Because there will be not only real-time communication in our system. There's going to be much other stuff. For example, if you open your Telegram, and let's say you were not online for 1 week, like how else you gonna get your messages if there was no connected socket the whole week to your device, right? Oh, sorry, there is also the comment from the Twitch. Love from the USA and GL. Oh, sorry, GL. What is good luck? Good luck. Thank you. I'm solving 1,000 LeetCode problems in 30 days. Nice. I got rated Chaos DAO. Interesting. Who is this guy? Who are you, man? No, legit, who are you? 1,000 LeetCode questions. No, I'm not nearly close to 1,000. I posted in Telegram, it's 300 something. 300, almost 50. Which is quite a lot. Right? I just want to check who is writing me. I code stuff, Chaos DAO. I hope I pronounce it correctly, Chaos DAO. 1,000 LeetCode problems. Day 3, day 2. This is actually cool stuff. Let's actually check it. So Twitch, Chaos DAO. Who are you, man? 1,000 LeetCode questions. This is crazy. Oh my god, no. Chaos Dev. Yeah, look at this guy. He's solving 1,000 LeetCode questions 4 hours ago. And this is some test I wrote there. Okay, interesting. 15 hours. Oh my god. Okay. 78 so okay, this is gonna be a long journey, my friend. This is gonna be a very long journey, I would say. Anyway, we're gonna go back to our system design. Sorry, I think I missed one more message from YouTube. So groups as the entities, no, we don't consider groups. So groups in this case gonna be just chats. So chat with different users is gonna be considered as a group. So now, yeah, why do we need chat service? And yeah, this is gonna be socket TCP, and this is gonna be HTTP. And why so? Because yeah, when you were not connected for a long time, HTTP S. When you were not connected for a long time, you need to go and to fetch all the updates, all the new messages, and you generally don't do it with the real-time connection and real-time updates. You just do it with the chat server, so with some paging you're like, yeah, return all the updates on all your chats, and then you connect to socket server and keep your real-time communication from that point on. Yes, and yeah, this is 2 services we're gonna have. Then, of course, for the history purposes, we're gonna get some storage. But which storage we want to have actually? EasyB, NoSQL, SQL. I think we can start basically with some, I don't know. In general, overall, during my last 7 years of experience, I pretty much never had big experience with NoSQL storages. But I guess there will not be that much difference. I don't know the limitations of the paging in the storages, because most probably when you scroll in your chats, you're gonna fetch more and more older data with history, and paging will be pretty handy here. And for paging, I know general SQL database and relational database should cover this thing pretty good with indices and with the range scan, B-trees and stuff like that. So I will put here actually for now a Postgres. Yeah, maybe because I'm stupid dev that doesn't know anything except Postgres, but Postgres is good, let me say this, okay? Postgres is really fucking good. So, oh my god, PG. So, what this guy gonna store? I'm quite not sure. Yeah, I think it should store just chats. We don't even need to store users here. I think users and user info should be somewhere in other microservice or service in general. Here we're gonna operate only with user IDs and nothing else, we don't care. So yeah, the structure here should be like, I don't know, there is gonna be table with messages, and this table gonna have user ID. Okay, let me actually write it because yeah, mouse is bad. So the structure should be message ID, it's gonna be user ID who sent it and chat ID, and that's it. For now, let's not focus on the features like replied to and stuff like that, but it can be also just with just additional columns. Of course, we're gonna add index for the chat ID. In this case, I don't believe we need index for user ID yet. Yeah, and message ID as a primary key gonna be index itself, as far as I remember, but if not, we're gonna make it index. And this one pretty much should be enough. Yeah, of course, we're gonna have some sequence number, but for now, let's do just timestamp, whatever. So this is gonna be kind of our structure. Yeah, and yes, and there are gonna be a bunch of clients connected to socket server every single moment. And socket server should be per chat, right? Because yeah, chat is gonna be kind of the room with the socket connection where we're gonna broadcast to all participants in the chat. So in general, if there is some socket that is listened to, all right, we're gonna connect to it. We're gonna connect to it with some chat ID or whatever. So there's gonna be some chat ID. And it will be something considered like, yeah, how are we gonna actually group it? It's interesting. Do we have LinkedIn? Yes, I do have. I don't know, you can just LinkedIn, you can find me here. Yeah, this is my LinkedIn. Yeah, NoScale might not be the right choice. Yes, I guess NoScale might not be. So now I need to remember and recall, so sockets, how do they work? Sockets. Oh, there is socket server, right? And this server is listening to, yeah, there is app. And it depends which sockets do we use. Because yeah, I want to group the socket connections per chat and how in general we can do that. So let me actually ask ChatGPT, generate me simple socket client server app. Should it be in the data of the socket, or because later on we would need to scale based on it, right? We would need to scale based on it. So somehow we need to catch it. So host port, okay, we have port. This is for our application and server that is listening to. Yes, and all. Yes. Send all. What does it mean, send all, by the way? Okay, so I would assume for now, we can actually implement it later on to see, but I would assume that, yeah, somehow we know, we can even have the mapping of the chat ID and the server address where the socket server is hosting the chat, basically. So different clients would connect to the same socket with the same chat ID. And then once one client sends the message, I'm sorry. Yeah, should be good. Once some client is sending the message, since it's bidirectional communication, as it's socket, it's TCP, right? And socket server understands all the kind of subscribers and broadcasting the message to all of them, to all of these clients, and clients is basically rendering it. Maybe also good thing would be to periodically poll the chat, at least some last messages in case we missed something, we lost something, or some interruption, whatever. But yeah, in general, I think this is how the sockets should work. Also, I haven't worked with sockets for quite a long time. Even forgot how they work. We can implement some POC, by the way. So, okay. Yeah, there should be chat server. Yeah, and maybe, yeah, some additional internal database, I would say. We would need some kind of load balancer or whatever that would tell us where the chat is served, meaning where is the socket server to which I should connect in order to be connected to this specific chat. So I would say maybe one more service here is needed, which I would name as a, I don't know, chat manager, or I don't know, whatever. But this kinda is internal thing. It also, oh, I think we are too close already. It also should have some database, but this should be completely different database because there will not be that many requests to it. Yeah, so I would put it here. It also should be HTTP. So whenever I want to connect to some chat, my client goes here and tells, give me the URL of the socket server to which I should connect in order to be real time with this chat, right? Yeah, if I want to send the messages. No, actually this chat manager gonna be highly loaded because, yeah, you remember this thing in Telegram when you have your chat here, blah, 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 blah. There is quite a lot of chats here and you are receiving updates about these chats as well. So actually, yeah, you might need to be connected to all of the chats here, which means you will send some batch request here with the chat IDs, and it will return you mapping of the socket servers to which your client gonna be connected. This is how I see it right now, at least. You're gonna optimize it, of course. You don't need to be connected to all of your chats, only to the chats that are visible, stuff like that. But in general, yeah. Maybe it's not the best idea. Maybe it's better to have. But no. I think this is how it should be. What's the time there? Your laptop show 8:59, but it's too sunny. Yeah, it's Prague, because it's Prague. Actually, there is sunshine here. So yeah. Okay, yeah, so this guy gonna be connected here. And yeah, in general, I would say that's it. So this is how I see the flow. The only thing here can be the problem that since we have this stuff that every single client gonna have, I don't know, up to 20, 30 connections to different web servers, meaning each client and each single user might generate up to 30 connections. So it's pretty high, constant. I mean, yeah, we can think about it a bit later. Yes, maybe also some security should be applied here, maybe some token with each package, whatever. So yeah, in general, the time right now is 9 p.m. It's just summer in Prague. Why should you use two different servers for sockets and chats? Sorry, don't understand. This guy is only serving you the URL of socket server to which you're gonna be connected. Also, it should be like that for the failover, because, for example, one socket server went down, you set up another socket server and you go here and update the information where this socket server is located and which chats it is serving, right? So, and once you did it, you basically don't have to go to this database anymore. So that's it. Yeah, and this chat server gonna be talking to this DB as well, this socket server. So yeah, it's working kind of in real time. So in two parallel requests, one request gonna be writing the message that just appeared, and another request gonna be broadcasting this message to the chat participants. I would say for now that's it. We have still a lot of questions are not covered. So yeah, let's deep dive further. Good. Not lost messages. Okay. So first, let's address the low latency. Yeah, I'm sorry. So before actually the broadcasting the message, you're gonna be putting it here to the chat store, and even in case some connection lost or socket server just got broken, it's no problem at all, because another socket server can catch up and all clients can just go with the last offset, last seen message and query messages that they lost, right? I guess no more questions from the chat. Good. Nice. Now let's cover low latency topic and go non-functional requirements. I think functional requirements should be good, because users be able. Oh my God, what's wrong with my English? Users are able to chat with each other and in group chat. So yeah, when there is some chat created, I go here, create the chat. Maybe I might add some users. Yes. Then for these, let's maybe go through the flow. So let's say I'm user A and there is user B, and we want to chat with each other. So in this case, I need to create new chat entity. This chat should basically have two users A and B, right? There should not be any other users. So we should also store this information somewhere. Maybe in chat manager basically also can be true, right? So there's going to be mapping like this. So there can be chat ID. there is gonna be user ID. So it's gonna be a bunch of, can be also different table, whatever. So chat ID, socket server maybe. Yeah, this is first thing. And another thing, maybe some additional table, is chat ID, user ID, to know which users we are connected on right now. And that should be enough, I guess. So this guy is not talking here. He's talking to, yes. And this guy gonna be only responsible for the messages and nothing else. Great. So, in case I want to create chat between user A and B, I should go to chat server, create the entries. Yes, this guy also should send some notification to socket server to pin this chat somewhere, and then write it here that there is some socket server that is responsible for this chat for these participants. It is created, and once it's created, we have, yeah, there should appear a chat for user B and A in their list. It can be real time, can be actually polling, because I don't think we're gonna have a lot of new chats created comparing to messages added, right? Yeah, and this chat, when it's queried, it's gonna have socket server to which both clients gonna connect with this chat ID, and we're gonna just start chatting. Every single message that is going to be added, it goes here to socket server. At least we try where this network connection. When socket server completely receives the message, which kind of should be guaranteed by TCP, it's either whole message or maybe, yeah. So once the message is here and we saw some end, the checksum is correct, we're writing it to the message database. So just pretty quick one. We might actually even use some append-only storage to have, because it's hard to understand the ratio of reads and writes at this point. I'm not sure how, yeah, mostly still reads should be, there will be more reads than writes, okay, I guess. So we're appending it here, and after we stored it, we broadcast it to other clients. And this is how they appeared. If client went online, it goes online again. First of all, the first thing it goes when it gets network connection again. We go to chat server, and based on chat offsets, we pull all the information both, from this database now. Yeah, so we refill all the messages that we lost. And again, we're gonna go to this chat manager and connect all the messages that are right now active on our chat list. I guess functional requirements should be covered by this. It feels like. I send you a connection request in LinkedIn. Okay, I will review at the moment because I'm logged off. Logged out. But yeah, in general, no problem. So, now let's cover non-functional requirements one by one. So first one is low latency. How are we going to cover low latency here? So first of all, we should understand that on our globe, users might be in USA, users might be in EMEA, so Europe and Asia. So these are three global zones where users might be. And it is not forbidden for us to have basically one chat including users from different areas. And in this case, unfortunately, we're gonna have a low latency because you know, whenever you put your socket server, if it's in this data center, these two gonna go through oceans to get to this server still, and this gonna be a lot. This gonna be, I don't know how even to calculate, but yeah, it's huge hop. So we should understand this. If we put this server here, these two gonna do the same, and so on, so on. So unfortunately, whatever you do, latency is gonna be huge here. But we can do optimization in case there are users in the same region or same geo, we call it geo, for example, geographical boundary or whatever. So if all of the users in our chat in EMEA, for example, for sure we're gonna catch this information first of all somewhere, and then when we receive chat server for the create chat, the request for create chat, we're gonna send some update to socket server to spin the new chat on the server that is located here in EMEA. So this is first trick for low latency. Just be as close to your users as possible. Yeah, other than that, since we're gonna have sockets, it's gonna be pretty quick. Yeah. Yeah, and in case there is network interruption, like not stable mobile data or whatever, well, you have nothing to do except to have low latency and periodically just catch the messages and try to connect to socket server, got interruption and so on. Scaling WebSockets are too complex, e.g. And what's your view about gRPC? gRPC is not real-time connection. It's kind of alternative to HTTP, but yeah, I don't see much preference. I think gRPC might be a bit quicker and a bit more performant because, you know, when you have static data serialization, so data in general should be smaller. And yeah, but I don't really remember the difference between gRPC and HTTP. I mean, in terms of what to choose in which situations, like the difference in protocols is huge, of course. Yeah, so that's it. And scaling WebSockets, yeah, we're gonna get back to this. We have 15 more minutes until I go. So yeah, this is the low latency topic. We just try to put our regions as close and put our users to the same region for the specific chat, and that's it. Yeah. I would say that's it. And if, for example, there is, yeah, I think should be covered. Now reliability. So, or in other words, high availability. Which components we can scale here? So clients we don't care. So sockets are going to be the last one. So chat manager. Maybe before that, let's define the APIs because I didn't cover it. So first of all, chat server. So this guy gonna create I'm not sure, it's a bit messed up here, to be honest. I'm not sure we actually need it because it can be done in scope of chat server completely, so I don't think we need it. Yeah, just like that. Yes, let me redraw it a bit this way. Yeah. So, what is the API? It should be post create chat, right? This is first thing that you're gonna have. There's gonna be get with batch request. Actually, it can be post, but yeah, have to be RESTful, blah blah blah. Get chats. And yeah, maybe we might have some put requests to add some participants to the chat, but this is not necessary. So once we have create chat, what is happening? What is happening that this guy creates the entry here, chat ID, and adds the user that is created chat, or just a bunch of participants straight away. Maybe we don't even need it might be just a list of user IDs. So maybe in this case we don't need a relative database. This can be NoSQL, I guess. Good. Yeah, we are adding participants. Socket server URL. And socket server URL we actually don't have at this point. So what we're gonna do, from the chat server, we're gonna send a request to some socket server in a clever way to realize which should be, like, what is the majority users and where they are located. If the majority of the users in EMEA, we're gonna have and go through some load balancer or whenever to reach out to this exact socket server deployed in EMEA. So this can be done maybe, how I should know? So I can have some list of socket servers. At some socket server manager, I would say even. So yeah, I'm sorry. This should be socket server manager. There should be component called socket server manager, and this guy gonna be just taking care about the infra, in the sense that this guy knows about all the socket servers deployed. There not be that much, maybe, I don't know, 1,000 of them, few thousands. It has them maybe cached in memory, because yeah, it should be pretty fast and it's not a big amount. It can be the socket servers actually can be in his small database, and I don't know, maybe even, no, file is not good as well. But yeah, it should be in some small database. Over here, very small. So yeah, like this. Why database? Because we need some durability and we need it to be like consistent, blah blah blah, to have transactions and stuff like that. And maybe we would keep one socket server per whole deployment, or per EMEA or something like that, because we don't want to have concurrency problems here, right? So whenever some socket server died, the manager can basically understand it, spin up another one and update all the data here, and maybe notify the clients connected to them based on this guy. Yes, so once we create chat, once again, we go to socket server, we ask to create or to pin some chat ID to some socket server. By pinning, I mean some socket server in specific location gonna receive the HTTP request over here, telling that this is the chat ID. You should expect connections from this, and that user ID. And whenever there is TCP connection made, we're gonna include chat ID and user ID, and maybe some signature for the security purpose. And this guy also gonna kind of check that if it's some weird participant, just don't include it, just reject the socket, right? So this is kind of already security here. Once we receive the response here, this is going to be HTTP as well, we're gonna save this information here. Yeah, there is consistency problem here. If this guy fails, well. Nothing bad actually will happen. We might just check whether chat ID is already created and pinned somewhere, and if yes, we just return the URL of this socket server. Sorry, I see the message on the chat. I'll get back to it ASAP. Just finish my thought, and then we basically gonna save the chat ID, socket server, and participants. From now on, this guy can be easily resolved from the chat server by get chats. By ID, it will return participant socket server to the client, and client gonna connect to a specific socket server. Yes, so this is just TCP, whatever, socket manager. I don't think we need to specify API, but maybe, yeah, let me add it, get or create or maybe pin chat, something like that. Get chats. Also for this guy, we want to get messages to catch up by polling and maybe periodically checking. This should be it. I don't like really how this one looks like, sorry. HTTPS, and this guy is also HTTP. Yeah, like this. Yeah, I don't know. For me, seems like that. Sorry. Questions. So, hello Andre, hope you are well. I'm working as iOS developer for 10 years. What do you think I have a chance to pass the system design interview without backend experience? Yeah, you easily can pass it. You don't need a backend experience for that. Only with general knowledge? No, with general knowledge you cannot pass it because you need specific knowledge. You need specifically study system design, practice the system design questions, read a lot of books. So basically you're gonna be theoretical backend developer, and this should be enough in your system design interviews. So now, how do we scale? So chat server is completely stateless, can be infinitely scalable. No problem with this at all. Storages, let's get back later. Socket server, we actually don't have to, or do we? It's also stateless, can be scaled easily. Can be scaled very easily. Socket server. Yeah, so this is interesting part, the socket server. There is also level 4 load balancers for them. But this is quite interesting stuff. How do we scale it? Because the socket server is responsible for scaling them and stuff like that. So I guess we can conclude that one socket server should be able to carry it should be enough to carry one chat. So in with 1,000 people, one good server can handle it. So we're gonna just pin and have mapping socket server per chat IDs. And by doing that, maybe, yeah, I don't think we need even load balancer. Like socket manager will be kind of load balancer for this. So it is in a way a load balancer, also manager for them. Yeah, so I think they can be scaled but not easily replaceable, because socket server manager should be involved to change the mapping so the clients will know where to connect. Yes, but it's still easily scalable. It is stateful in a way because it keeps the chat ID pinned. It listens. Yes. In a way it's stateless, in a way it's stateful because it just has the port that it listens to and only the connected clients. If it goes down, let's say, it is lost, I don't know, region outage, whatever. What is going to happen, client's gonna ask again for this chat, for chat ID. This socket server realized that this guy is dead. He'll gonna spin another one server and just basically pin the socket connection there, and that's it. And that's it. Yes. So I would say they can be infinitely scalable, or I mean in this case partitioned. If it's gonna die, we can just replace it by new one. So yeah, let me also state that this is scalable completely. Now storages. So let's first go to this one. This is socket server manager, which manages mapping chat ID to the socket server, or yes, this mapping exactly. There is a duplication of data actually. I don't really need maybe we can have it in one service, I don't know. No, I still believe it should be separate one. So yeah, how it should work, that this guy has all the socket servers. Maybe it has also chat ID, but it doesn't have participants, no metadata, just socket server URL and chat ID pinning, and that's it. That's basically it. He knows about all the socket servers. So this data is pretty important. Yeah, and this database should be scaled as well, and it should be maybe scaled by chat ID. So basically general partitioning should be good. For high availability, yeah, there will be a huge read load, much bigger than, because it's more than we need to resolve where is the socket server for a specific chat, then create new chat and got the server for it. So I would say we might have a lot of read replicas, and on top of that we're gonna have partition. For the replication, leader follower should be just good. Like, I mean, in worst case, if we lose some socket server, we might have some logic that like eventually this guy gonna be dead or refreshed or whatever. Oh, sorry, I missed the chat as well again. Thank you for answer. Yeah, no problem. Resources for learning DSA so I can do LeetCoding. Basically start doing LeetCode and learn algorithms as they go, check all the solutions and learn the algorithms. There is not a big chunk of algos you need to know. So cover graphs, so basic algorithms maybe up to Dijkstra, so BFS, DFS, Dijkstra, maybe this topological sort, you're good. Learn binary search, 100% you should do it. Bunch of sorting algos like quick sort and merge sort, you're good. Some bitwise operations, I mean arrays, linked lists. So for data structures, have a good understanding of hash set, linked list, stacks, queues, of course. Maybe trees, that's it. Not that big. Just I would say for interview you just need go do your LeetCode, and meanwhile just follow the algorithms and solutions and learn them as you go. Thank you for answer. Yeah, no problem. Resources from which I can learn data structures and algorithms concepts. Just answered. I would suggest take you forward for DSA. Okay, don't know about this one. Resources for which I can learn data structures and algorithms. Sorry, I just answered. Good. So this guy is pretty scalable. And now for the messages. Well, which key we should take to scale it? I would say, yeah, also I should add mapping here. The mapping should be chat ID socket server. And we're gonna have a lot of socket server info, like what is the region and blah blah blah, whatever. So in this case, we're gonna have index on chat ID for sure, and we're gonna partition this by which key? Yeah, I would say by chat ID. By chat ID here. By chat ID here as well, it can be partitioned. Yes, by chat ID. We're gonna store all the messages for the same chat in the same database and same partition, which seems quite reasonable for me. And so partitioning by chat ID and replication. To omit consistency problems, I would still say leader follower should be good here. And here we have also chat ID maybe. Yeah, by chat ID partitioning again. Shit. Some bug. Yeah, and that's it. That's it for now. I would say this would ensure scalability and reliability in some sense. Durability kind of covered by databases. Ordering guarantees. Network interruptions. In case of network interruptions, client just gonna go and do polling and try to reconnect to socket server, should be good. Ordering guarantees, now the most interesting part. So first of all, we forbid to do parallel client requests from the same user. What do I mean by that? Is that, yeah, client should wait before previous message that I press send to is sent until it allows me to send another message. This is first thing, which is already gonna be a good ordering. Another thing that on socket servers is we're gonna have one socket server, one socket port listening to the same chat. What we can do is we can have thread per chat. So there is only one single thread that is processing chat updates and sends the messages. So it's gonna assign pretty monotonically increasing daytime up to milliseconds. And then we just gonna use this timestamp as a kind of sequence number and put it to our database, and that should be pretty much enough for ordering guarantee. With regards of at least one guarantee, if we didn't receive, so if we sent through the TCP but we didn't kind of get confirmation that it was received and client went offline, and socket server still received the message and saved it, well, there might be some kind of deduplication mechanism. So for example, client might add some IDs like GUID, these universal IDs for each message, and store it locally. So after that, when client retries, it will go and try to send the same message with same ID, and we would detect that it is duplicate by just checking this ID in our database. One way of doing it. Another way of doing it maybe is that we just don't care and we try to send it again. Even if it is duplicated, well, all right, it can happen, right? Nothing bad actually will happen. And before that, of course, what will prevent it is that we can, yeah, there is polling, right? get messages for specific chat. So as I told you, once the connection is broken here, or sorry, done here, so we lost the connection. Before to try to start communicating through the sockets, we do get messages and we get the latest update, and only after that we send, and maybe you will detect from that that the message you want to resend is actually already there. Yes, so that will be it. Scalability, network interaction. Pretty much, I would say I covered a lot of stuff. I would need to think about it a bit more, and next stream, we're gonna watch the Facebook staff engineer or Meta staff engineer doing this system design. I'm pretty interested what didn't we include and cover it in this system design, so let's see. So answering the chat messages last time, and I'm gonna go. So yeah, sorry, let's connect. Maybe we can learn together. Yeah, you can connect, guys, no problem. Why not use Redis for the cache instead of socket database? Yeah. I mean, caching might be, like, I would say for the messages maybe. Yeah, in all of these layers for the storages, there should be cache for sure. I would say, of course, cache gonna be here in this WebSocket manager. It's gonna be cached for sure 100% because it should be very quick to resolve it. Cache can be here as well. And for the messages, I'm not sure there should be cache, to be honest. Because mostly, like ideally, right, we want to get update through the socket, not through the poll. So I would expect most of our traffic for the message is going to be through the socket server anyway. So maybe here we cache, we don't need to cache it. Yes. Have you gone connect LinkedIn, Discord? How much math do I need to know for DSA? Not that much, to be honest. Not some sophisticated stuff, like basic math up until, I don't know, 6th, 7th grade should be enough. Do I need to know Java collection framework? No, for sure you don't need. But yeah, got used to at least some language, so you know the data structures, the generic computer science data structures in this language. This is important. So if you're gonna use Q, you should know how to use Q in your language. Okay. Oh, in the Twitch we have 4 people. It's quite unusual for my streams. Usually on Twitch I have no people. Okay, guys. I think that will be it for today. I need to go. We are done with streaming. It's already kinda dark here. The most beautiful sunshine. I don't know. Can I show you it to you? Yeah, I will just show you. Look at this. Look at this. Boom. The most beautiful sunshine here. The picture is actually much worse than it is in reality. How the work environment of your company? Actually, Microsoft is pretty good, pretty solid. We are pretty compliant, pretty nice people are working here. I'm pretty happy with my team and stuff like that. So yeah, in general, I like it. But the thing is, yeah, you most probably heard of layoffs. 9K people just let go, and I know quite a lot of people from the Prague office. Well, not a lot, but I know that people got laid off from my office as well. But hopefully, I will not get laid off. So let's see. The only thing is layoff. Anything else is pretty good. I don't have anything to complain. Okay, so thank you for being with me, guys. Actually, appreciate it. For those who joined, we will continue next stream. Please don't forget to subscribe to Telegram. I will just add it as a later on. It is in the description because all updates are there. Sorry, can you give me roadmap as I'm just starting? Should I do development on the side? If yes, what tech stack technologies for making projects? Sorry, I will answer this question next stream, so please join because yeah, it will take a bit of time. So yeah, it was good time guys, and yeah, see you next week. Bye bye.